started. Hello. Welcome, everyone. Welcome back to the Ready for Merge show. I am so excited for this episode. I'm your host, Christine D. Kim, and this is a special Ready for Merge show, the first of its kind. It is a live guest episode. It's going to be a episode that is focused on the Fusaka upgrade, on the Ethereum upgrade. This is going to be a full it's going to be all about Ethereum today. And we're going to be getting into Fusaka, the good, the bad, the ugly, everything that went well about the upgrade, everything that didn't go so well. And I have with me two very special guests to do this Fusaka retrospective. We have Barnabas and James. Hi, Barnabas.
Hi, everyone.
Thanks for being on the show. Hi,
Thank you.
James.
Hey everyone.
Barnabas is a DevOps engineer on the EthPandaOps team, and I like to think of you, Barnabas, as the taskmaster of Ethereum, the one that is always pushing developers to go faster.
Yeah, that sounds about right. So my day-to-day job is basically communication with all the client teams and making sure that the deadlines that we set out is actually achievable, and we want to make sure that we can ship specific features within a set out time frame. And in order to achieve that, we have to make sure that we're not really delaying the next DevNet, the next spec freeze timeline, and this is the only way we can make sure that we can ship like 2 forks a year, which is what we did this year.
Yeah, it's quite the feat. It's you guys did it this year in 2025, which is amazing.
Yeah.
I definitely want to talk more about some of those the timeline for this upgrade, which I feel like was pretty like first of its kind. But for our listeners who maybe also aren't super familiar with you, James, I wanted to share that James is a Prysm client developer and someone that I think has a lot of hot takes. Obviously, you haven't shared them publicly, but I'm really excited to have you on the show because I've heard your hot takes behind like just like DMs and stuff, and I think they're really good takes. So I kind of like to think of you as the client developer, just with good takes about what's going on with the Ethereum protocol development.
Yeah, thanks, Christine. I joined the Prysm team about 4 years ago. I guess I was the front end engineer on Prysm. So for those who don't know, there was this UI as part of Prysm, and then I slowly went into client work throughout the years.
I didn't know that. Well, I'm not a node operator, which I feel like is probably something that I do need to fix immediately. A lot of my readers and my subscribers on Substack have been telling me that's a major no-no. I need to spin up my own node. But it's good to know that there's a nice like user interface with the Prism software. Probably something I should look more into, especially if I'm gonna run a node myself one day. But both you, James and Barnabas, you guys have been involved in Fusaka from its scoping to its shipping on mainnet. First of all, just want to say congrats on the upgrade going well. Ah. Oh, and
Yeah,
I also have a
it
little.
was a massive feat. In the end of the day, we we wanted to ship pure data together with Spectra. That was our original goal set out a year ago, well, over a year ago at this point, in the Kenya interop in that was May or June of 2024. And then later that year, we realized that the scope of PLS is just so massive that it will have to be shifted out and put into the next fork. But in the same time, we knew that we have to like keep working on it and not just push it after Pectra to start working on it, because the amount of work that had to be done on the consensus side is just massive. And this was like the main reason that we were able to ship the Fusaka in this calendar year.
Yeah, that long runway is really the reason why we're able to ship now. Like Barnabas said, back in May, I think we had our first dev nuts. The work started about a month earlier in April. And for the listeners who don't know, every year or so, the core devs try to get together as like its own sort of private conference kind of thing where we hackathon the next hard fork and try to really push um, and sprint forward on the features. And it's kind of crazy to imagine that PureDust was going to be part of Pectra before, and we essentially had like different groups, um, and I'm sure some viewers probably saw on Twitter. There's this photo with all these core devs. We were in Africa, and we were working on this, and then by the end we're like, oh no, like there's all this stuff to do, and then even with shipping it now, it still felt like there was so much to do around this feature.
Yeah, I feel as though Prysm in particular, there was a point in time when developers and all the client teams were thinking about a mainnet activation date, and Prysm wasn't ready. Prysm, like the team was still trying to get its mainnet release ready, and the date for mainnet was set before the Prysm client team was ready with a mainnet release. Was that? I thought that was a never before. That was like kind of like a norm shift, I guess, in the development process. That kind of freaked me out. Did that freak you out, James? You were like, "Whoa! Like, why did the date get set? We said we weren't ready yet."
Yeah. I feel like this is the first time we've been so optimistic about all the timelines. There were issues found in the Hoodi testnet, and they were pretty complex issues to try to resolve. And um, we were scrambling to sort of get patches for those, as well as it'll take some time to find root cause, and then we also wanted to see if we could get backfill in. It didn't make it to that one, but uh, yeah, there were issues, and then we scheduled it, and we didn't even have the first Hoodie BPO. So um, yeah, very optimistic. I hope, like, ideally it would have been we schedule mainnet sometime after the last fork on the test nets. It's very optimistic to set the
To be
mainnet
fair,
date.
we already had BPOs on Sepolia and Hosky before, and Hosky actually went through the first and second BPO. Sepolia went through the first and was, I think, right before Hoodie went live on Fusaka. We had the second BPO, and the first BPO on Hoodie was also just a day or two after the mainnet releases had to be made. So, and we still had a month in case of some big problem happens. So I think in terms of like timelines, if you want to do like two forks a year, we cannot really make it any longer than this. It's already a very long process. We went from the first week of October onto the first testnet into hitting mainnet 2 months later. So this 2 month window, if you consider that we want to ship a fork in 6 months, then that means we actually want to ship a fork in 4 months and have 2 months of just like testing on testnet, which means we have to have 2 months on DevNet and 2 months of actual core development. That includes also the scoping of the fork, deciding what should make it in, what shouldn't make it in. So it's like very tight. And I think this 2 months of rolling out on testnet and on mainnet is a very long time.
Yeah, and
Hold
from
on,
the
just
client
sorry,
developments.
pause.
Oh, go ahead.
We're gonna go, James. Barnabas, can you pick up the gain a little bit on your mic, if that's
Yeah, sure.
okay? Thank you. Just so that your voice is a little bit louder. Thank you. I was having a little bit of trouble hearing. But sorry, go ahead, James.
I was gonna say, in order to sort of practically do this multiple fork shipping, we're essentially breaking core devs into these little mini teams within each client team. So for Fusaka, essentially we've layered three different forks because development of Fusaka or Pectra Part B started all the way back in April of last year. So we were still shipping Electra and dealing with all the Electra related issues. So some engineers worked on that, and then other engineers worked on started Fusaka, and then some other engineers, at least for the Prysm team, started on Glamsterdam. So it's like you sort of have to figure out how to work that out. And I really wanted to take some of this time to call out, at least for the Prysm team, the leadership from Manu, one of the devs on the Prysm team. He joined from the EPF, which is the Ethereum Protocol Fellowship, as with like a lot of other members as well on the Prysm team. It's essentially this internship for senior engineers from the foundation, and you get to work on some problem with a client team. But yeah, without Manu's sort of like leadership on this PureDOS feature, it would have been really like exponentially harder to ship on time. I'm not sure if viewers on this call know about each of the members on the teams, but at around the same time, one of our other senior engineers that's like specialized in networking sort of took a step back and sort of left the Prysm team. So there was sort of a gap here, and yeah, I just wanted to call that out.
Yeah, no, for sure. I want to know about, I think part of this Fusaka retrospective is calling out some of like the amazing MVPs that had such a pivotal role in shipping the upgrade and making it happen on mainnet. So yeah, thanks for highlighting Manu on your team. I hear him sometimes on the ACD calls giving updates, but of course, just from the updates that he gives, I wasn't aware of like, yeah, exactly his role and what he does. One thing that, so I still want to spend some time looking back on how Fusaka went before we move forward, but I also want to do just a quick tangent from what I was going to ask initially for you guys, because Barnabas and James, you guys have just kept saying, well, like if we're going to ship 2 forks in a year, this is how it has to be done. You know, it has to be this. What is this motivation? Like, why do you think that it's so important that Ethereum ships twice a year? Like, I have been talking to some people on X, and I think for me, there's this little misconception that if Ethereum upgrades more, ETH price will stay high. And that is it is extremely bad understanding of markets, of crypto markets, and especially around the value and the narrative behind certain assets. Like what drives the value of Bitcoin is very different from what drives the value of Solana. And Ethereum, it is kind of in its own stage of maturity as an asset. And I wonder if this desire to ship really fast and desire to ship 2 forks in a year is based on a misunderstanding of what drives perhaps ETH price. But I'm just curious to know from your guys' perspective, like what is really the driving motivation to get 2 forks done in a year? Like why is that the highest aim right now?
Yeah, so my take would be is predictable timelines and basically making sure that we can ship as many features as we possibly can. What we want to do is create an environment where Ethereum is basically improving as fast as it can and adjusting to the world around it basically as much as it can. And if we just do 1 fork a year, that means that everyone will be pushing their own EIP like there's no tomorrow. Everyone is going to think that, you know, if it doesn't make it into this fork, then it's probably not gonna ever make it, or it's not gonna make it in in the foreseeable future. If we say that we're gonna be shipping 2 forks, that means that the scope of those specific forks can be significantly smaller, and we can have a predictable time frame when a fork will hit mainnet. And this allows all the stakeholders, all the layer twos, everyone to prepare, even just mentally, that in around June and in around December, we're gonna see hopefully an Ethereum fork, mainnet fork.
Do you think that checks out with fossil conversations? People.
Yeah, so people are pretty scared that fossil is, if it doesn't make it into Amsterdam, it's never gonna make it. But we basically said that we would like to CFI it into HFork already, and hopefully that can also make it into Ethereum mainnet by end of next year. And this is the kind of conversations I think we should have a lot, that we need to set up a pipeline of features that we want to ship, and then we need people working on it ASAP. We need to have the spec rebase on top of Fusaka, and then rebase on top of Gloss in by March, let's say. And then we can start implementing Fossil on top of all the Amsterdam features, and making sure that we can keep the timeline going and be able to ship H star by December of next year. And this way, we can make sure that lots of EIPs can make it into the fork, but not as much as we did for Pectra, for example. Like Pectra was massive. Fusaka was a much smaller scope. In terms of PureDeath itself was massive, but the rest of the EIPs, they are straightforward. I mean, they have to be worked on a lot, finding the right repricing EIPs. That is a ton of work, but in terms of implementation, that's a one-liner change.
Can I come in with my take?
Yes,
I guess for the financial part, this is not financial advice, but there's an insider joke that like every time we ship, the price drops. That's clearly not the case for this fork, but like in previous forks, it was kind of funny to watch. It's like, oh, we released something, up, price dropped. But I think Barnabas really sort of hit the nail on the head. I heard this analogy that Ethereum wants to shift from sort of, if you could think of it, taking flights somewhere to like a train model. So it's like if you miss the flight, they're like, oh, too bad. Like you don't know what the next flight is, and you're gonna have to like sort of fight with everyone else to get a seat. Otherwise, and the politics are already like, it could be better, but like that kind of model would just make it worse. And sort of switch that to a trade model where, oh, I missed this train. I know that the next one's going to come, and we'll just get onto that one. And so I think that shift is good, but of course there's a lot of framework stuff under the hood to sort of get that to get the teams to that state. And this is a sort of praise to the EthPandaOps team. Like we wouldn't have been able to ship Fusaka this year if there wasn't all the new testing tools that the PandaOps team provided. I think in the Kenya interop, that was the first time many of us used Kurtosis, this testing package. Essentially, for the listeners who don't know, the EthPandaOps have provided this this kit that is used with kurtosis to run a local devnet, and you can essentially spin up your node environment locally and then sort of test out these different scenarios um, in a lot more flexibility than what we had before. Before, it was that there were cases where it's sort of built into the client software to have these local dev nets, but then it needed all this setup. So you have to have these custom scripts to create the custom Genesis state and do all this crazy setup, spend an hour to figure that out, and then finally do your 5-minute test only to see it like break and then go like tweak everything again. Um, so these testing tools really helped on the iteration process.
Yeah, we spent a significant amount of time on making sure that our testing tools are very dev-friendly, and one might say they are even user-friendly. Like you don't even need to be a developer in order to be able to run a local DevNet at this point. Majority of my time was basically focusing on making sure the Ethereum package is always up to date with the latest possible spec version, and always ready for the next iteration of DevNet and the next version of the spec. And this really unlocked a huge portion of developers' time not to worry about, a Prysm dev doesn't necessarily know how to compile even a Nimbus client, and how to run a Nimbus client might take him 10, 15 minutes of his time just look through the docs. And with the Ethereum package, all you have to do is just set a single string, and you said that you want a Nimbus client, and you will get it. And yeah, this is what we try to basically take away all the thinking that someone would need to put into launching a DevNet, and make it as easy as possible, as well as a bunch of other extra tools that we created just for PeerDAS, including the column viewer on Dora, and Dora just has been getting a bunch of updates this past 6 to 10 months. Everything PeerDAS and non-PeerDAS related.
And for our listeners who don't know, Dora, as in the Ethereum blockchain explorer, like kind of a similar tool to Beacon Chain, correct?
Right. It's just a lightweight Beacon Chain Explorer. The whole idea was that Beacon Chain the Beacon Chain Explorer is a very heavy application that requires a bunch of system resources to run locally. It can be done, but it's also not very performant when you run it on a local environment. It requires a proprietary database structure, which locally you don't have available unless you're paying for it. So this is why we decided to try to do something that doesn't really care about attestation performance. We don't care about if one validator is better performant or the other. The idea is that we just care about the general health of the network and have all the attestation stuff just stay in RAM. We don't really care about it long term, and that's why the Beacon Chain Explorer is actually a lot better. It keeps history of all the attestations of every single validator, which is why it requires so much more resources.
Yeah, I don't think even the main website was working Beacon Chain during the Fusaka upgrade. I noticed that quite a few people were sharing that the website was down. Um, on the topic of tools, can you also, Barnabas, just share why or how a user could use the latest live custody monitoring tool from EthPandaOps? I saw that go live, and I need the TLDR on like how to use it, what to be watching for on that site.
Right. Do you want me to share my screen or?
Yeah, that sounds good. And I'll link to this in the show notes for anybody who wants to try it out themselves after the recording.
Just give me one sec.
Yeah. James one. Oh no, okay, great. We'll do this and then we'll.
Right. So this was also created by our team. The lab is basically using a bunch of contributors' data in order to fetch attestation information and block proposal information, and just letting us know how long did it take for an attestation to show up on the network. And the custody view is new as of PureDeath. It's basically enabling us to take a closer look at which specific column in a given epoch, or at a very specific slot level, like in this case, column 3 is available by which of the peers. And this is done using custody probes, which is we're using a tool called the Desmond. So Desmond was created by our lib P2P team. It's basically probing a bunch of random nodes. I can enable here the live view. You can see that the slots are randomized. Basically, this is a slot random between the expiration period, so the 18 days till to the head of the chain, and we use Prysm, which is a forked Prysm client, to fetch the information of a specific column of a random peer where Prysm is connected to. And we're probing for random columns, basically. And these 4 random columns, it will return either with a success or with missing data or some specific failure. So this allows us to basically monitor the whole network randomly and making sure that every single column is available on the Ethereum mainnet at very high confidence. And that's basically what you see here as well.
These tools are getting so much cooler.
Yeah, especially this prober, it's very, very cool, I think.
And would the main people that want to use this primarily be like layer 2 sequencers and operators?
Most likely, yes. So the layer 2s would be the main people or the main companies that would care about blob availability, especially blob availability within the first 18 days, where we say that we're gonna have those available. And then after the 18 days, those blobs can expire, basically.
Could layer 2s come to this site and retrieve, like, I guess they'd be able to retrieve the blobs within the 18-day period using some of the data on this site?
No. So the data on the site is only for visualization. You would need to go to the P2P layer and fetch the blob using some client like Prysm. And then they would do backfilling. I'm not sure if backfilling is implemented now in Prysm. I hope so.
It's not released yet.
Okay.
That's gonna come out very soon here in the next few days. So
Right. So maybe I can just shill Lighthouse in the meantime. So Lighthouse now has column backfilling basically all the way till 18 days. And even if you restart your consensus layer client, they are going to backfill till the expiry period.
Okay, that's fascinating. So use the tool, the live custody monitoring, for understanding what's going on with your blob transactions, seeing its propagation throughout the network, and then for the actual retrieval of those blobs and utilizing that data, you use directly your node, like a Lighthouse node or Prysm node when it's ready to retrieve the data.
Yeah,
Blob
exactly.
data. Okay.
Yeah,
Fascinating.
and just today, we also decided to see how it would be if we start spamming the network. We saw on Twitter that a few people actually noticed it, that the blob fee actually went up. We were spamming for one whole epoch, and we were sending 15 blobs at every single slot. this cost us, I think it was as close to 0.1 ETH or something like that. But it was worth it to be able to see that the network can actually handle a sustained load of 15 blobs. And this is in preparation of BPO2, which is going to come to the mainnet in about 3 weeks or 4 weeks.
And speaking of, you guys didn't notice. I mean, it's great. I mean, just from the stress testing that you've done, I feel like that's a good sign that the network is strong and resilient. Because BPO1 went live yesterday. You guys still haven't noticed anything amiss, correct, after that upgrade?
We had one of the relays basically having some unupdated Reth dependencies in their R builder, which caused a few invalid blob base fee calculation errors, which resulted in orphan blocks. It was very few, and then later on they also produced a few blocks that didn't include any blob transactions, which meant that they were not actually orphaned, but yeah, not including blob transactions is not nice for liveness. So, but they rolled out an update and it seemed to have fixed everything, and the participation went back up into 99+%. And during our spamming, also, we didn't see any significant drop in participation rate, luckily.
That's great.
Yeah, and BPO2 is going to actually increase the target blobs to 14, which is our current almost max. And the max is going to go to 21. So that's going to be another very significant increase in blob availability.
A bit of a tangent on that, but when blobs go to a target of 14, I believe it was you, Barnabas, who was talking about setting a flag, like a max blob flag for local builders so that they can customize their target if they're not able, whatever reason for their bandwidth or resource constraints, to be able to build blocks with the target. Is that on the radar for the Prysm team, James? Like how important, like how
Change.
it's an EL change. Oh,
Yeah.
okay, I see.
Yeah,
Okay.
because the local block building is handled by the EL. So we currently have two ELs that have implemented this as a flag. It's Nethermind and Reth. I've tested both of them. It's working fine. They haven't made a release since mainnet yet, but I'm expecting that going onwards with BPO3 and 4 and 5, we're going to need to have a few improvements, such as this one, implemented by all the different ELs in order for us to be able to push the BPO count even higher.
Okay. Speaking of, let's start looking ahead, I guess. What are some optimizations or kind of things that are still needing to be done in the aftermath of the Fusaka mainnet upgrade? We just did BPO1. Obviously, BPO2 is coming. But James, you had mentioned even before recording that there's some pretty important fixes that you guys are still working on in the client, and that users should be expecting quite a few releases over the next couple weeks. Can you give us kind of the overview of what you guys are looking ahead to?
Sure, yeah. I guess it's important to mention that even though Fusaka shipped, there's plenty of things that are related to Fusaka that we still need to continue to improve on. So of course, the first big one that's coming is backfill. That's going to be in the 7.1 release of Prysm. And that's going to just let you get older data columns after checkpoint syncing to a specific point, and then you can get your old data columns as needed. Prysm is also looking at state diffs. We have there's this essentially performance issue that sort of Fusaka has made it worse with saving the state for archival. It just takes a really long time to save it. And so we're switching to a different architecture for that, and that should greatly speed that up, and then sort of reduce any performance issues around that. But there's also like other smaller optimizations that we'd like to sort of take a deeper look at. One is right now there's this concept of the super node. So you store all of the data columns. The question is, you only need half of that, the 64, to reconstruct the full blobs. So can you store just the 64 and then the 128 proofs and sort of reduce storage for that? Because from a user experience perspective, I believe that Fusaka have made it a little bit more difficult for operators, and there's plenty of areas where we can improve on that. There was one thing I forgot to mention on 7.1. There will also be semi supernodes. So you'll store the 64, and then you can reconstruct again the 128.
Okay, so backfilling and then also the half supernodes. Because I remember, I think it was the Aztec Layer 2 team that had been asking for a feature like that, or some of the Layer 2s were. So yeah, those seem like features that are in high, they've been like asked for by Layer 2s.
Yeah, ideally we would have shipped it with the mainnet release. Again, we scheduled the date way before, but we'll have it ready soon.
Are there any other kind of features in Fusaka that you think are under optimized, or that you think won't actually be utilized as much as the effort that it took to put in?
So I can bring up a few examples of Spectra, not really Fusaka, because Fusaka literally just went live like a week ago. So we don't really know what is a feature that's going to be underutilized, or what is not getting enough attention. But like Spectra, for example, we had the MaxCB, which allowed validators to merge their validator balance and basically just be able to earn more ETH on their validators without making any withdrawals. And this feature has been severely underutilized by large node operators, unfortunately, which means that the validator set is still fairly big. Luckily, it's not growing as rapidly as it did before, and we did see some migration of 002 credentials, these max EB credentials, but it's nowhere near as much as we expected before we were working on Spectra. And I know that consolidations was one of the main problems to implement in terms of implementation detail on the CL side. It was something that we could have basically just say, yeah, if you want to have a 002 validator, just exit and make a new deposit with your new credential. We would have seen probably even less people migrating using that structure. But honestly, we could have shipped Spectra months earlier, I think, without the consolidation part.
Yeah, I would agree with Barnabas on that. I guess in terms of Fusaka, there's a situation where we did, I guess we spent some resources. It did cost a couple days, I guess, but the perfect pure DOS situation where essentially everyone has unique data column information, which is extremely unlikely on mainnet. It's there's a lot of supernodes on mainnet. So I guess that would be an underutilized feature, but again, it's good to have these kinds of security backups that are proven.
Do you know, James, the distribution of types of nodes post Fusaka, as in like what percentage of nodes are super nodes on Ethereum, and what percentage are?
We just made
That's a Barnabas question.
yeah, we just made a tweet about that today.
You did?
We have
That's
17.6% supernodes.
okay.
And we have approximately 13.5 thousand nodes, and almost 50% of them are non-validating nodes, and about 23% are running less than 8 validators, so less than 256 ETH. It's a very nice even distribution. It's a lot more supernodes than we anticipated. In all of our testnets, we anticipated about 15,000 unique nodes, and out of those 15,000, we estimated that there's going to be about 10% of supernodes. And having 17%, that just means that the overall health of the network is significantly better than we expected.
Any features that you guys think, in hindsight, should have been in Fusaka but didn't get into Fusaka?
EOF. I'm just kidding.
James, we don't have time for that on this episode. I'm just kidding.
No,
You can't open up that can of worms right now.
EOF would have been nice, in my opinion.
Okay.
Yeah, I know that EOF is a very dividing topic, but it would have really helped down the line with future scaling, in my eyes.
So I guess being more on the practical side, like I thought maybe we should have done the 2D pure DOS. I mean, there's a lot of user experience issues with 1D. I think that is just the reality of Ethereum development. You want to go fast, so not all the features will be 100% perfect. But again, we want to get into this like train kind of model where it's incremental improvements, and we'll get things ironed out eventually.
For our listeners that don't know, EOF is the upgrade to the Ethereum virtual machine, like the execution environment of Ethereum, how people are coding and executing their contracts. James, quickly, do you want to just elaborate a bit on the difference between 2D and the 1D version that we have in Fusaka?
Yeah, I guess we're just going to the full DOS aspect right now. Like the data that we have, in order for us to have unique data across nodes, we essentially stretch the data. I guess we stretch the data in one direction right now, and then we slice it up into pieces, and then those are the data columns. And then in 2D, you would stretching it essentially in two directions, and you would provide even the smaller chunks to each of the nodes.
So maybe you would only need like 1/4 of the columns rather than half.
Mm-hmm.
Even less. So the idea is that we're gonna have partial messages and cell level deltas coming to Ethereum as a basically lip-P2P improvement. So this is an update that doesn't require a hard fork. What we're going to do is we're going to roll out client by client and be able to request a small cell instead of the whole column in case you're missing one specific blob on it. So this could unlock the further improvements for BPOs 3, 4, and 5 down the line.
Potentially another thing that will be rolled out asynchronously from a hard fork. Is that what you're saying?
No. It requires, so BPOs do require a hard fork because it is actually a hard fork. It's just, we don't change anything but the block count. Like we don't introduce a new EIP, we don't introduce anything. But this partial messages, this could be rolled out in between BPOs even. You just won't be able to do partial requests from a node that has not yet updated. But then it would just fall back into requesting the whole column. But in case that there's a significant number of CLs that have updated to this partial the partial request, the partial messages, then those peers will be able to serve the partial messages back to the one that's requesting it. So the idea is that maybe we can start working on this now, and hopefully by end of January or February we can roll it out for a few nodes, validated that it's all working fine, and then hopefully we can have all the different CLs rolled out in a BPO as well. But again, it's not a consensus breaking change, so it doesn't actually require a hard fork. But it's just nice if we align it to a BPO, because at BPOs we do actually change the fork digest and we change everything on the EL as well. So it is a hard fork.
Anything to add there, James, about the rollout of the 2D peer tasks?
No,
This is not 2D peerless. This is
The
just
partial message.
This partial messages is just an improvement to the 1D. This is to save bandwidth. It's not about storing less data. So we are still storing the same amount of data. I can actually, I was working on the past 2 days on a data calculator because I've been hearing from everyone that, hey, how much data do I have to actually store now? I can show you a quick demo on that also.
I think there were quite a few stakers on the ETH Staker Discord channel. I was talking about it on a prior episode of node operators just trying to prepare for the upgrade to see how their requirements were changing.
Right.
Okay, yes.
This is Hoodi. We don't have the new version rolled out on mainnet yet, but it's going to be pretty much the same on Hoodi or mainnet. And here you can just select how many validators you're running. You can select 0, and then here you can select the time-based statistics. So if you care about 18 days, you can see that even as a node operator that runs 0 validators, you still have to store 13 gigabytes worth of block data. And as you increase this, let's say you have 30 validators, then it's 100 gigabytes. And if you go,
That's a really cool tool.
If you go all the way up to 128, anything over 128 is just going to be this. This is 420 gigabyte. And here we have an average of 14 blobs per block. So Hoodi is actually very, very busy with blobs. We have a bunch of 21 blobs, as you can see here. That just pulls up the average.
There's a audience question in the chat. Wads2S asks, should target blob count be determined by validators like gas limit? I personally think the gas limit is already, it is determined by validators.
Yeah. No. Okay, sorry. So like we have the base fee and the blob base fee. And as we start using more blobs, we are pushing it up. So we are aiming always to stay around the target. And if you go above the target, it gets more expensive. If you go down, it's going to get cheaper. Same way as we handle for normal transactions. And we now have a 60 million gas transaction.
But the block gas limit is technically, like, if the majority of validators voted to increase the block gas limit, it could increase. But you can't necessarily do that with the blob
Right. Yeah.
space, like
Yeah.
block space. I mean,
So I do have a hot take on that. I think we shouldn't allow validators to change the gas limit either. I think
yeah,
client teams should hardcode that, and because it's not something that a normal validator would need to ever change realistically. It should be hard coded into the client, and it should not be user configurable, in my opinion. Otherwise, it's a huge security problem for Ethereum in case someone wants to maliciously behave right now. They can.
I mean, if a validator had, yeah, was able to change the block gas limit themselves, I feel like they could do much worse things on the network than just like double the block gas limit if they wanted to. I feel like it's already determined by developers and client teams. Like when the client teams set the default, the block gas limit changes and it doesn't change otherwise. Like I feel like client teams and developers already have such a strong, they already in practice set the block gas limit, even if in the protocol level, the rules might not explicitly say so.
Yeah, there is a configuration for it, but yeah, I guess typically people would use the default.
Yeah. There were times I feel like in early Ethereum's history when it was still proof of work where miners did initiate their own increases at the advice of like developers. But yeah, I feel like with the more frequent upgrades and Ethereum developers now moving perhaps even faster than validators are keeping up, I feel like developers are really on the ball about, yeah, the highest block gas limit that's safe for the network, which is really a testament to you guys for how focused and like attentive I feel like the development community as a whole is being on scaling efforts. One other question, because I know we're kind of running up on time. Barnabas and James, you guys were talking earlier this episode about how pivotal EthPandaOps has been in the tooling and testing for clients. Is there any concerns about EthPandaOps being kind of like taking over testing of client teams' capabilities and there being an over reliance on the EthPandaOps team for testing? I remember there was a time during the Fusaka upgrade where Barnabas was like in the Discord, like, you guys, there's so many client teams that are sending out releases like last minute. It's like we can't keep it, like we need to test all these. And I was thinking to myself, I was like, that's a lot of pressure on one team to try and ensure that clients are up to spec and doing well. And I just wonder if there's too much now shift in responsibility and duty to this one team to ensure that clients are ready for mainnet. Whereas before, perhaps client teams had to have their own testing capabilities and really ensure, and the responsibility was more on them. Curious to hear your guys' takes on that thought.
I mean, for sure, EthPandaOps is carrying like a huge weight on their shoulders, but I wouldn't say that like everything is on EthPandaOps. Like just speaking for the Prysm team, we have a lot of also internal tooling. We work with our internal SRE. There's also this sort of security audit kind of competition that's going on. So there are other eyes sort of looking at the code base, not just, does it spin up and sort of work. That being said, like there is so much to test, and we didn't cover it yet on the podcast, but during the Fusaka hard fork, there was a Prysm issue, and it caused a sort of a big outage in the network, we were quickly able to provide a temporary solution. There is a 7.0.1 sort of hot fix release so that you no longer need to use the flag to sort of restore your node for mainnet. But there is a lot of testing, and it's not just the EthPandaOps team. There's no way that the EthPandaOps team could cover all the scenarios. There's chaos testing. There's all these different situations. I mean, with this mainnet issue, it's kind of crazy because we tested this on Hoodi for a month with this fix, and obviously there was something else missing in this, but it's clear that Hoodi isn't the only network that sort of compares to mainnet. And even for Sepolia, there were issues that we saw in Hoodi that Sepolia couldn't cover. And so there is the overhead is just all these different edge cases to consider and try to do different things on the network. And I think that's like for the viewers, if you're helping on the test nets, trying to run these test net nodes, like that is one of the biggest like support things that you could do for Ethereum is to run these nodes on these test nets during the development phases and help report some of the issues that go there.
Yeah, I gotta run not just a mainnet node, but also testnet nodes. I'm gonna get there. I'm gonna get there.
You can just run Prysm locally on your laptop. You can get up and running by end of the day if you want.
Any thoughts to add, Barnabas, on kind of the growing role of EthPandaOps in shipping upgrades on Ethereum?
Yeah, so I really hope that EthPandaOps never becomes a bottleneck. My post regarding not pushing out, last minute updates was really just in terms of I really hope nobody has a regression that we haven't tested. It's something we have seen before where a client team had a good release and then they broke it and then they had to do another release to fix the previous regression. And we just want to make sure that that doesn't happen. We have done multiple shadow forks in order to make sure that the client releases that we've mentioned on the Ethereum blog post is the one that we've tested, and those were fine. And if you give us a last minute client release, then that's basically just we're gonna be flying blind. And I'm not saying that we shouldn't have these kind of releases, but maybe we can wait till after the fork is done, especially if it's not like a huge breaking change that you found some very big security vulnerability in your code and you have to push that release out. Then it's completely different.
Any final thoughts or learnings looking back on Fusaka that you would want to kind of share on this episode for posterity, like looking ahead to future forks like Glamsterdam or even beyond?
I think we did very well in terms of pipelining. As I mentioned earlier in the call, something we need to keep doing for H star fork as well. Heka is going to be big. Glamsterdam is already massive. We need to basically rip out all the ERPs that are not a must-have for Glamsterdam and just shove it into Heka, and then start prototyping and testing. APPS is going to be difficult, and I'm looking forward to it. But yeah, it's going to be big, for sure.
James?
I guess from like a developer side, there's some things that we keep having to sort of relearn. What happens is when you have all these overlapping forks, people don't want to like merge in code for the next fork while one fork is going on, because they're afraid like it'll cause like other issue. Like you don't know, like, is it this fork is causing issue, that fork causing? So finding better ways to break features down and then merge it in. I would also say one of the learnings from this fork was a lot of the code changes were like at the fundamental sort of base level. It was like the code that got us here won't get us there. And it was a lot of refactoring and sort of supporting adding these new features. So probably like half of the code changes for PureDOS was refactoring the existing code so that it could handle the new specs that were coming in. So sort of taking an earlier look at that space and sort of having sort of a guess on what types of features it's touching so that there's enough engineers that are familiar with what needs to change at the base level.
Yeah, that's a good point because as things are being done also more and more in parallel with the scoping, the implementation, the block gas limit increases, perhaps the P2P networking optimizations, the ongoing work with perhaps blob scaling, as all of these are starting to timeline wise just like merge. I think there's like such specialization in what's being worked on each that, yeah, on the ACD calls, when you bring up one topic like, okay, block gas limit increase, it's not something that like most of the developers are even working on anymore. Everyone's kind of focused on their own thing. And I think that definitely impacts decision making. Like this topic around trustless payments with EPBS, it's a topic that it was discussed earlier, but no one had the specialization other than say like two people on the call, and then people just kind of trusted like, oh yeah, this must be the decision that we have to make. And now I think there's just a lot more discussion on it because the information wasn't known. Everybody was just specialized in doing their thing on something else, and I kind of foresee that as yeah, still continuing on in Glamsterdam. And I also still see like even with the Heka upgrade, just the like same controversy around what gets into a fork. Even if developers ship twice a year, the same kind of controversy of like, well, this is a code change that we can't wait for another 6 months. Like it has to get in this fork or it's not going to go in ever, which is like, again, I think a conversation that perhaps maybe with more repetition in this process, perhaps those fears will lessen. But I don't know. I guess we'll see.
Yeah, I heard this quote from Preston actually. Um, so I mean, the best case is everyone's happy with everything, but the second best is everyone's a little bit unhappy with everything, and then that's where it's fair.
That's a good quote.
Yeah, if everybody is happy about everything, then it wouldn't be as public as it is right now. Because, yeah, as humans, we just cannot make everyone happy, and we just have to accept the fact that some people will be unhappy about the changes we make, and yeah, we just have to deal with it and just push forward.
Yeah, no
Yeah,
process is perfect.
get on the next train. Get on the next train.
Get on the next train. Well, thank you so much, James and Barnabas, for sharing your honest thoughts with me about the Fusaka upgrade. I really appreciate the time and your guys' insights.
Thank you for having us.
Yeah, thanks for having us.
And thank you, everyone, who is listening to this special guest episode of Ready for Merge, the first again of that I've done for this podcast. And I'm sorry that we couldn't get through all the audience questions. Some of them will have to be touched on, perhaps on a future episode. I'd love to have you back, Barnabas and James. Perhaps to talk about Glamsterdam stuff. Some notes on the back end. I'm going to link to some of what Barnabas was sharing on this episode in the show notes. I'll also link to James and Barnabas's social media profile so you can follow their work, everyone who's listening. If you like the show and liked what we talked about, please be sure to like and subscribe to the show. I'll be continuing to cover Ethereum protocol development and Bitcoin development, as my regular listeners should already know, on this show and also on my Substack. And for next week's show, next week's Ready for Merge show, I want my listeners to know it's actually going to be the final episode of this year. It's going to be the last one before I go on a bit of a winter break. So yeah, for next week's show, it'll just be a bi-weekly brief, the ones I usually do, giving the high-level overview of Ethereum and Bitcoin protocol development. So stay tuned for that. Thanks again, everyone. Have a good rest of your weeks. Bye.
Thank you. Bye-bye.